So you got some data, you got some results. Why are we interested in IQ? I don't have a good answer for that, just so you know. I don't have a good answer for that. I don't know why we're interested in IQ. I just don't know lots of studies involve it. I think it's because it's a measurable thing. You can actually get an IQ measurement. You can put a number to something, and then you can take those numbers and do things like find their averages, their standard deviations, their percentile ranks, their medians. I'm not saying that can tell you anything. I'm just saying that's, I think, why they're used, just because it's easier to do that than, like, say, a pain scale or something along those lines. At least it feels like it's, we talked about it in 243. You take this test, and then you take your mental age and your chronological age, and you form the ratio, and there's your IQ. Exactly. Good. Remember the moron, imbecile, and wait, there's three. Moron, imbecile, idiot. Idiot. That was the third one. Yes. Moron, imbecile, idiot. All depending on what range you fall into. Very good. Very good. Very good. So we want to see, for some reason, whether acute head trauma impacts IQ. Take a look. Take a look at the graph. What do you think? Remember, average IQ is 100. And these folks, before the head trauma, had an average IQ score of 100. That doesn't mean everyone had an IQ of 100. It means they averaged 100. So what do you think? Has their average shifted at all? A couple votes for yes. Maybe well. It's a little bit skewed. I think we could actually test this and argue that it's Bellish enough. I mean, it definitely is skewed. It's definitely skewed to the left side, but I think it's still Bellish enough. So the question, that's a very good point actually, Dina. The question I have for everybody is, okay, so we have, Deanne. Too many consonants. The question I have is the bell curve now different than the bell curve that it was? We saw in 243 that IQ is bell-shaped. It's bell-shaped, the high point's at 100. Where's the high point of this one? 95 to 100? So somewhere a smidge left of 100? So what's the next question? It looks like it's lower. Is it significant? That's every question we're going to ask from now to the last 3 weeks of class is always that. Yeah, look at the graph, it looks lower, but is it measurably lower? And this is the kind of thing you can't do by just looking at a graph. You can't just look at the graph and say, yes, it's lower because on this graph it's lower. This graph is a sample, yes? Right. If we sample it again, we might get different results. So what we have to do is take the sample results and adjust them for inferential use. That's where 244 differs from 243. 243, we took a sample, called it good. Sample standard deviation, 2. Blah, done. We can't do that anymore. You can't just say blah, done, because if you draw a sample again and this comes back 5.5, blah, now I'm confused. What you have to do is take the results you have, assuming they're a good sample. You're starting to see now why it's so important to have a good sample. This sample is standing for your whole population, okay? Which is why we have things like sampling methodology classes. So based on that, what do you think? And the answer is, I don't know. I can't do it without crunching numbers myself.
Well,
so
it would also be nice to know where these particular people fell before there.
They averaged 100. They averaged 100.
Because they're in population, or because we know for sure these
because the research study claimed that. And again, this is where I have to pull back to the limitations of the study, what I was able to glean from the study. Yeah, they averaged 100. Did the average go down? Good point. I mean, I love the questions.
Well, because you never know, maybe people that are lower have more head.
But they're defined lower. Originally lower, they averaged 100, so they averaged normal. So I see your point. I see your point. I see your point. But this is just trying to identify the variable. Normal IQ originally, what happens after? Grab a template, G. Let's start working through it, yes? Yes. What variable are we going to test? P or mu? Ah, we have to test mu now, don't we? Because we're testing an average IQ. Shah. Circle your mu. Beautiful. Define the variable. Step 2. So we're testing mu. What mu are we interested in? Be as specific as you can with respect to the problem we're trying to solve here. I'm going to pull this out of the way. Sherry, go louder for me, please, if you don't mind.
Effective head trauma on IQ scores.
Can I just twist it around a little bit differently? You got everything in there you need to have in there. It's not so much that we're testing the effect of head trauma. It's just, is the IQ now lower than it was before? So, but I'm not going to say the lower pit. The variable that we're testing is the average IQ. Yes, of head trauma sufferers. Yep. We'll get to the lower bit in the hypotheses. Is that fair? Good, 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 good. Of head trauma sufferers. Yes. And I guess it's acute head trauma, isn't it, too, if we're to be super specific. Acute.
Okay.
Good. That's our variant.
Maybe that's what chronic would be.
I'm saying it's a different study, right? I'm saying that's a different study. This is acute head trauma. Boom. Baseball bat, head, boom. Test the IQ. Done. Fair enough? Sorry. Wait. Put too fine a point on it. Fair enough? Define your hypotheses, my friends. Let's define a hypothesis. I think that's the step 3. Yes. Step 3, H0 and HA or H1. Again, I don't know which one your textbook is using. If you're even using your textbook, you might not be. That's totally fine too. Say that again. That's the null, isn't it? Because if we think, we have a claim that we think it's lower. We don't know if it's significant or not. So can I go with this first? Just because that's what we're trying to test. We're trying to see if the average IQ of those with acute head trauma is actually lower than 100. I'm not trying to say it's 5 points lower, 6 points lower, 10 points lower. I'm just saying it's lower. We'll argue the significance of what lower means in later courses, I guess. Sociology and psychology courses, I would imagine. What's the null going to be? That it didn't change, exactly. And you can write this any of a couple different ways. Most folks are going to, actually most of you are going to say what? Greater than or equal to. I heard somebody say just equal. That's the status quo. The status quo is just that it's equal to 100. My mathy brain wants to make it this, greater than or equal to 100, because my mathy brain wants it to be exactly the opposite of the research. Either one's fine. Either one's fine. Just when you go out into the journals and you're pulling the studies from the journals, just realize that you might not ever see anything except an equal sign in that null. I don't know why. Somehow that changed 15 years ago, and now it all looks like that. So you're just experiences you might have. Ready to go?
I don't know what this symbol is called.
Oh, alpha equals
Okay.
5%.
Does that
I snuck that in. Go ahead.
does that have anything to do with H1?
It has everything to do with the test itself. Renee is commenting on the little alpha symbol there, to see, parentheses, alpha equals 0.05. That's 5%. Guess what that 5% is standing for? The significance of the test, which is the complement of the confidence. And the reason I snuck that in there, we're always going to be testing at that in this class to keep things consistent, but you're going to always see that kind of stuff. I'm trying to get you almost as used to the symbols as I am the mathematics that you're going to see out there as you consume these journals. So when you see alpha, that's a chance of a type 1 error. So you're allowing yourself 5% type 1 error. I want to come back to errors in about 10 minutes after we finish this test. Maybe it might be a little bit longer. We'll see how long it takes. But alpha and beta are the 2 types of errors. You very often see alpha talked about like this. So alpha equals 5%. You're allowing yourself a 1 in 20 chance of error. Fair? Good. Now, I want to...
Alpha means type 1?
Alpha is the probability of type 1.
So
Yeah.
false.
You have to, well, that's what 95% confidence means. It means you're going to be wrong 5% of the time.
But is that
Yes, in the direction of a positive test result, exactly. Speaking of direction, I want to draw a null curve. That's kind of the reason I left you that little space next to it, is to put the null curve with it. So if you just scratch a little curve over here, I want to slap a bell curve up. I know we're not guaranteed a bell curve in the population, but we are guaranteed a bell curve in a sampling distribution. That's what central limit theorem guarantees us that. And I'm going to bring down this guy, and I'm going to call him 0 like we always are. But underneath that, I'm going to put the contextual number that really is there, and the number that really is there is what? 100 for 100 percentage points. Yes. Or whatever, 100 IQ points. Very, very nice. Very, very nice. Where do we think IQ has gone? We think it's going down, yeah? So we're looking for a cutoff over here somewhere that leaves the alpha equals 5% in this tail. There's your alpha. 5% chance of type 1 error. Outlier. What's the next obvious question?
how far?
Good. How far did our data go? Is our data here? 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 We have no way of knowing that right now, do we? I can't do this kind of math in my head. This involves subtraction, division, square roots. That's too much crap to do in my head. So I want to put that on the back burner for right now. Just keep that curve ready. Our question right now is, where is our data? Our data is on that curve somewhere. And based on how the data looks, you guys have already said that it looks like it's going left of where it should be, left of 100, yeah? So what sign should the test statistic have on it?
Negative.
Everybody buy that? It should be negative based on that, if our gut feeling is correct. I don't think there's any goofy outliers that are pulling it positive. I think we're going to have an average below 100. We'll see it in a minute. We'll play it in a minute. But let's keep going with the template for now, before we get into the crunching. I want to get to the crunching. I like the crunching. It's kind of the fun part. But at least let's keep identifying things like the errors and stuff. What would the two types of errors be defined? I mean, you got type 1, type 2. What would a type 1 error be in this case in context? Type 1 error in this case in context. Stacey, go ahead.
False positive.
Good.
It would be that it did lower. We said that it did lower the rate, but it didn't.
Boom! We said that it lowered IQ, but it didn't. Very nice. So maybe this is just good. Assuming this could generate a type 1 error, we don't even know if it can yet. We would have to have a small p-value, yes, in order to get a type 1. Good, thank you, Stacy. Type 1, false positive. We said average IQ was lowered, comma, when in fact, comma, it was not. False positive, crying wolf. Very nice. That's one potential. That's a small p-value potential. How about a big p-value potential? Type 2 error. What would a type 2 error be?
Saying acute head trauma does not, on average, does not lower the average IQ.
Good.
When it does.
When in fact it does. Everybody hear that? I want to say it nice and loud. Thank you, JC. You finish the test, you get a big p-value, and you put your hands up in the air and you go, well, oh well, we thought smacking people over the head with a baseball bat would lower IQ. Looks like it doesn't. So you're going to claim that no, it does not appear that acute head trauma lowers IQ, comma, when in fact, comma, it does. That's a false negative. That's a false negative. That's a false negative. All right, step 5, all you, which type of error would be worse and why? And this is going to be different for every person. It's going to be different for every person. So what do you think would be the worst and why? If you had to pick one. I heard a couple type 2s, I think. I heard Jamie type 2, and Angie type 2. How come, Angie? Why type 2?
I think if you put it into context, saying you don't need to wear a helmet because our studies show.
Oh goodness, you're going even further. That's good. You're going even further than I was going with this. Thank you. Because you know what? Acute head trauma is fine, assuming IQ is meaningful, which I think we have to kind of do in the context that we have to assume that this IQ is important. So assuming that IQ is important enough, I'm not saying it is wrong, I'm just saying assuming it was important enough to make an experiment about, missing the fact that it has changed to Angie is more valuable than maybe falsely crying wolf that it hasn't. Good, I like that. A couple nods, an agreement with that, totally fine. Anybody say type 1? Lauren, go!
We now say these people are less valuable based on this arbitrary number that doesn't actually exist in our test. Possibly in a group.
Oh, maybe if we get a significant result, we flag acute head trauma, it might artificially create a situation that other folks... That's good, I hadn't thought about that. Sarah likes that one too, that's good. This is what I like you guys to think about. I mean, this is the non-mathematical part to each problem. Think about which type of error would be worse in your opinion. And it might vary depending on your field too. It might vary depending on your history of studying things like IQ or head trauma or medicine or anything else for that matter. Good. Anybody else? Those are fantastic. Cool? Alright, you pick your favorite, or least favorite, I guess. Next up, which distribution? Oh, be brave. T. You gotta use T. You cannot use the Z for this. I challenge you to try. Try to go back to the test of the TI and try to make it work. You can't. You can't. Now, I want to go to the TI real quick and show you a couple reasons why you can't. There's one that looks like it almost should work. Grab your TIs again.